1. So question 1 says we have been given point A, which is 4 comma negative 6, and point B, which is 2 comma 4. Okay, so this we can call it x1, and this one y1, and this one x2, and this one y2. Okay, so they want us to find the gradient. So gradient, the formula is y2 minus y1 over x2 minus x1. Okay, so our y2 is 4 minus y1 is negative 6, so you have to put it in brackets. You can't write two signs, okay, without brackets. Then x2 it's 2 minus x1 it's 4, so 4 negative times negative, it's going to be this one is 4, negative times negative is plus 6, 2 minus 4 is negative 2, so 4 plus 6, 10 divided by negative 2, 10 divided by negative 2 is negative 5. So this is the gradient. We go to question 2. So question 2, they want us to find the gradient of the parallel of the line parallel to the line that we have been given, which is 0, 4. We pick two coordinates from there, 0, 4 and 2, 0. Okay, so we can call them x1, y1, and x2, y2. So when you try to visualize, we have got this line, then it has a line parallel to it. Okay, so lines that are parallel have the same gradient. Okay, lines that are parallel have the same gradient. So for us to find the equation of this, we need gradient. The gradient, we can get it from this, since we haven't been given 2 points on which this one passes. For you to find gradient, you need 2 points like this. Okay, this line they have given us 2 points, but the parallel line they haven't given us 2 points. So we're going to use the 2 points for this one to find the gradient. Once we have the gradient, then we're going to use the gradient. Since it's the same gradient, we're going to use the gradient to find the equation of the straight line. Okay, so we go. So we have m y2 minus y1 over x2 minus x1. Y2 is 0 minus 4, y1 over x2 2 minus x1 0. So 0 minus 4 is negative 4, 2 minus 0 2. Negative 4 divided by 2 is negative 2. So this is the gradient of the first line. Now it is the same gradient for the parallel line, because the gradient of the first line is just the same as the gradient of the second line, which happens to be the parallel line. So they have the same gradient, like I said. So now we're going to use to find the equation of the parallel line. There are two approaches. You can use this m y2 minus y1 equals, sorry, it's m y minus y1 x minus x1. Okay, so you can pick any of the given points since it was passing at the origin. So at the origin here it's 0, 0 always. Okay, it's 0, 0. So meaning that our x1 is 0 and our y1 is 0. So it's going to be, what's our m? Our m, we've calculated that it's negative 2. Y minus 0 equals x minus 0. Okay, so it's going to be negative 2. Y minus 0, y equals x minus 0, x. If you want, you can do divide by negative 2 both sides. Okay, so that this goes, you have y is equal to negative x over 2. Okay, oh, I've swapped the formula. It's supposed to be like this. I don't like this formula, so I just wanted to demonstrate. It's x minus x1 equals y minus y1. Okay, so m it's negative 2, x minus 0, x1, then y minus 0. So it's going to be negative 2x equals y. So our answer is y is equal to negative 2x. This is the equation of the parallel line. Now, the one that I like is just you do the standard equation of a straight line. Y is equal to mx plus c. Y, where there's m, you put the gradient. The job is to solve for c. So you get your 2 points 0, 0. This is x1, this is y1. So where there's y, you put 0, -2. Where there's x, you put 0 plus c. So 0 is equal to -2 times 0 is 0 plus c. So 0 is equal to c. Therefore, our final equation is going to be this, but with c replaced with 0, which is -2x plus 0, or better not write it because 0 is nothing. So y is equal to -2x. We go to question 3. Here we want to find the length of the line. So the length of the line, we can represent it like this. Okay, so the formula, we know it's square root x1 minus x2 power 2 plus y1 minus y2 power 2. Sorry, this is y2 power 2. Okay, then we have the 2 points, which happen to be -3, 3 and 5, 9. So this is x1, this is y1, this is x2, this is y2. So it's going to be square root of x1, which happens to be -3, minus x2, 5 squared, plus y1, which is 3, minus y2, 9 squared. Okay, so it's going to be square root of -3, -5 is -8 squared, plus 3 minus 9, -6 squared. So it's going to be equal to -8 squared, 64, plus -6 squared, 36, equals square root of 100. What's the square root of 100? It's 10. Don't forget to put the words units. We got question 4. Question 4, they had given us two equations. The first one was 3y. This is question 4. 3y plus x equals 6. The second one is y is equal to kx plus 12. So they are saying we find the value of k if these two lines are parallel. So parallel lines, we know, is it parallel, perpendicular, or perpendicular? So there is a relationship between the gradients of perpendicular lines. For parallel lines, we know that if we have two gradients, m1 and m2, then they are equal, like this. But for perpendicular lines, if we have got two gradients or two lines, the one having the gradient m1, then the other one having the gradient m2, and they are perpendicular. To perpendicular is to be like this. Okay, so if the gradient of this one is m1 and the gradient of this one is m2, then the connection is -1 over m2. Okay, so let's tackle it. So we need to find the gradient of the first equation and that of the second equation. So the first equation is 3y plus x equals 6. What's the gradient of this one? When you have been given an equation and they want you to find the gradient, you just make y subject. Then, in short, you write this equation like the standard equation of a straight line, which is y is equal to mx plus c. Okay, so y should be the subject. Then x should be the first one after the equal sign, then this c, which can be any number. So here we can take x this side. So instead of it becoming like this, 6 minus x, we are going to, because positive x, when it goes to the other side, it becomes -x, we're going to write it like this, plus 6. Why? Because we want x to be first, so it will be -6. I mean -x when it goes to the other side. Then 6 as positive, it's a positive number, so that's why this positive, that's where the positive comes from. Then from here we can divide everything by 3. Of course, others can do this. Divide this side by 3, divide this side by 3. But when you're doing coordinate geometry, the easiest and the easiest way, so that you don't waste time, is to divide each number individually by what you want to divide, so that this goes, you have this -x over 3 plus 6 divided by 3, 2. So what's the gradient of this? Okay, the gradient of this is the coefficient of x. It's negative, the invisible one here, over 3. that's the coefficient of x, and that's the gradient of the line 3y plus x equals 6. Now we have known the gradient, so let's continue. We have known the gradient, it's negative 1 over 3, but they want us to find the value of k if these two lines are perpendicular. Okay, so what's the gradient of this one? What's the gradient of this one? Okay, if we compare it to the standard equation of a straight line, we can see that the gradient is k, m is k, so the gradient of the second line is k. But we know perpendicular lines, the relationship is m1 is equal to negative 1, m2. Therefore, and it's also true to say m2 is equal to negative 1, m1. Okay, it's true. Okay, so we can say our m2, which is k, is equal to negative 1 over our m1, which is negative 1 over 3. Okay, negative 1 over 3. Okay, so how do we simplify this? So I'll come back. So it's k, negative 1 over negative 1 over 3. So this means divide, so it's just the same as negative 1 divided by negative 1 over 3, which you can change this to times, then this goes on top, this goes on the bottom, it becomes 3 over 1 negative. So negative times negative is positive. 1 times 3 is 3 over 1, which is just the same as 3. Okay, but this is a waste of time. This is a waste of time. Okay, so our m1, it's negative 1 over 3, right? Negative 1 over 3. So our m2 is k. So our m2, which is k, is just, so when they are perpendicular lines, if the first one is a fraction, what you do is you take this up, you take this down, and you change the sign. So it will be 3 over 1, and the sign changes. It was negative, it becomes positive. If it was positive, it could have become negative. So our k is 3. So you can do it the longer way or the shorter way. It depends on you. Okay, so let me say that again. If the gradient of the first line, it's a fraction, then to find the gradient of the perpendicular line, you just do you take the denominator up, the numerator down, and you change the sign. Okay, if it's negative, it becomes positive. If it's positive, it becomes negative. Okay, we go to question 5. So question 5, we were given this equation 5x minus 6. So they are saying they want us to they want the coordinates where the line passes the y-axis. They want the coordinates where the line passes the y-axis. So visually it's something like this. We have y, we have x. So it's something like you can say this, it passes here. So the rule is, on the y-axis, the x values are always 0. And on the x-axis, the y values are always 0. That's the rule. So anything you're doing with graphs, on the y-axis, the x values are 0. And on the x-axis, the y values are 0. This is the x-axis, y value 0. This is the y-axis, x value is always 0. So wherever this line passes, the value of x there, it's 0. Doesn't matter where it passes, but the value of x is 0. So this one, 3y, 5x minus 6, for us to know the coordinates, we have known one thing. Since they have said where it passes the y-axis, we know that x is 0. The job is also to know what y is at that particular point. So what we do is we put, where there's x, we put 0. Where there's x, we put 0, and we solve for y. So it's going to be 3y. 5, where there's x, we put 0 minus 6. So it's going to be 3y. 5 times 0, 0, 0 minus 6 minus 6 divided by 3, divided by 3, this goes. So y is equal to negative 6 divided by 3 is negative 2. So the y value is negative 2. Therefore, the coordinates are 0, negative 2. We start with the x value, then the y value. We go to question 6, where we have to calculate the length. So we have been given 2, 6 and negative 3, negative 6. So x1, y1, x2, y2. Okay, so they want us to find P2. PQ. Okay, so PQ square root of x1 minus x2 power 2 plus y1 minus y2 power 2. Okay, so it's going to be equal to square root of, what's our x1? Our x1 is 2 minus, what's our x2? Our x2 is negative 3. We put them in brackets to avoid double negatives here. Power 2 plus y1 6 minus y2 is negative 6, again negative 6 there in brackets, power 2. Okay, so it will be negative times negative, it's plus, so it's 2 plus 3 power 2 plus negative times negative, it's plus, so it's 6 plus 6 power 2. So it's going to be square root of 2 plus 3, it's 5 power 2 plus 6 plus 6, it's 12 power 2. Okay, so 5 squared is 25, 12 squared is 144. Okay, so 25 plus 144, it's 169. Okay, what's the square root of 169? It's 13. So it's 13 units. You have to add the word units. I've run out of space, that's why I haven't added. We go to question 7. So question 7, we have of course the two lines N and M. So N we have been given is 3x plus 2y equals 6. Okay, so for us to know the equation of L, we need first to find the gradient of N. Then we use the gradient of N to find the gradient of L. Since they are parallel lines, we know that two lines which are parallel, they have this relationship. Gradient of L is equal to negative 1 over gradient of N. Okay, we know where N, where L passes. So once we find the gradient, it will be simple. So we make, to find the gradient, we make y subject. So we can take 3x this side, it becomes 2y is equal to negative 3x plus 6. We can divide everything by 2. Okay, this goes, we have y is equal to negative 3 over 2x plus 6 divided by 2, 3. So our gradient is negative 3 over 2. So this is the gradient of N. Okay, so the gradient of L, we're going to use what I explained in the question, where I said that if two lines are perpendicular and if the gradient of the first line is a fraction, or even if it's not a fraction, if you can write it as a fraction, you just take this up and this down, then you change the sign. So this is going to be 2 over 3. It's negative, so it becomes positive. So this is the gradient of line L. Now that we know the gradient of line L, let's find the equation of line L, because we know that line L passes at 5, 4. So we're going to say y is equal to mx plus c. So y is equal to the m, we got 2 over 3 x plus c. We know it passes at 5, 4. So this is x, this is y. So we can substitute. Y goes here and x comes here. Okay, so it's going to be 4 2 over 3 times 5 plus c. So it's going to be 4 2 2 times 5, it's 10 over 3 plus c. We can take this side, it becomes 4 minus 10 over 3 equals c. Okay, so I'll continue it from here. Okay, so it's 4 minus 10 over 3 equals c. So we can put 1 there, common denominator 3, 4 times 3 is 12 minus 1 times 10, 10 is equal to c. 12 minus 10, it's 2 over 3. Okay, c. Therefore, the equation of line L, it's y is equal to 2 over 3 x plus 2 over 3. C is 2 over 3, gradient is 2 over 3. We go to question 8. So question 8 is just like the same. We have been given the line 2y minus x equals 3. So let's find its gradient. So we take negative x this side, it becomes 2y is equal to x plus 3. We can divide everything by 2 so that y is a subject. We have x over 2 plus 3 over 2, making the gradient of this first line as 1 over 2 because there's an invisible 1 here. So the efficient of x, it's 1 over 2. So the gradient of the perpendicular line, which I'm going to call M2, is going to be equal to, you take this up, you take this down, it becomes 2 over 1, and you change the sign. If it was positive, it becomes negative. If it is negative, it becomes positive. So negative 2 divided by 1 is negative 2. So this is the gradient. Now they want the equation. Okay, we know where the line passes. So I'll continue it from here. So we have m negative 2. So the standard equation of a straight line is y is equal to mx plus c. And the point where this perpendicular line passes is negative 4, 1. Okay, so this is x, this is y. Okay, therefore this will come here and this will come here. So we're going to have 1 equals m is negative 2, right? M is negative 2. Okay, x is negative 4 plus c. So it's going to be 1 is equal to negative 2 times negative 4. It's 8 plus c. Okay, so 8 can come this side. It becomes 1 minus 8 equals c. Negative 7 is our c. Therefore, the equation is y is equal to negative 2x, negative 7. We go to question 9. Okay, so question 9, we are given these 2 points. They wanted the equation of the line, so we're given 3, 4 and 7, 12. So we know the equation of a line, it's y is equal to mx plus c. Okay, so we can first find m. We know m is equal to y2 minus y1 over x2 minus x1. We know this is x1, this is y1, this is x2, this is y2. Okay, so it's going to be m is equal to y2 minus y1. We're talking about 12 minus 4 over x2 minus x1, 7 minus 3. 12 minus 4, it's 8. 7 minus 3, it's 4. Okay, so our m, 8 divided by 4, it's 2, right? So our equation, this one, since we found m, becomes y is equal to m is 2x plus c. Okay, so we continue now, since they have told us that it passes through 3, 4, where x is 3, so we're going to put 3 here, and y is 4, we're going to put 4 here. Okay, so y is equal to, so y is equal to 2x plus c. Okay, we want to find the value of c, so we said y is 4 and our x was 3 plus c. So 4, 2 times 3, 6 plus c. If we take 6 this side so that we remain with c, it becomes 4 minus 6 equals c. 4 minus 6 is negative 2 equals c. So our final answer is going to be y, 2x, then of course it's supposed to be plus c, negative 2, right? Because c is negative 2, so we can simplify these two. Y is equal to 2x, positive times negative, negative 2. Next, there is the length of a line. We're given a is equal to, a negative 3, negative 1, and b 0, 3. So this is our x1, y1. This is our x2, y2. So a, b is equal to square root of x1 plus x2, comma, squared. Sorry, it's x1 minus x2 plus y1 minus y2 squared. Okay, so we can substitute. So x1 is negative 3 minus x2, it's 0 squared, plus y1 is negative 1 minus y2, 3 squared. Okay, so it becomes negative 3 minus 1 is negative 3 squared, plus negative 1, negative 3, negative 4 squared. So this becomes negative 3 squared, 9, negative 4 squared, 16. So 9 plus 16 is 25. Square root of 25, 5 units. Okay, so we go to question 11. So question 11, they have given us the gradient. Okay, they have said the gradient is -3. Sorry for the noise. The gradient is -3. So they want us to find the value of y given these points. Okay, so we use the formula for gradient. We know m is equal to y2 minus y1 over x2 minus x1. What is m? M is -3. We call this x1, y1, x2, y2. So it's going to be y2 is y minus y1 is 5 over x2 is 0 minus x1 is -2. So it's going to be -3, y minus 5. 0 minus minus 2 is 2. So we can do cross multiply. -3 times, or 1 times y minus 5 is y minus 5. -3 times 2 is -6. Okay, so let me continue it from here. Have I done everything properly? Okay. Okay, so it's -y, -5 equals -y, sorry, it was -y. It's actually y minus 5 equals -6. So we can take -5 this side, then it becomes y is equal to -6 plus 5, and our y is going to be -6 plus 5, 1. Okay, so the coordinates of B are 0, -1. We go to question 12 where we're looking for gradient. So this should be cheap. -12. We have A, which is -3, -1, and B, which is 0, 3. Okay, so gradient, we know it's y2 minus y1 over x2 minus x1. So what's our y2? So this is x1, y1, x2, y2. So what's our y2? Our y2 is 3 minus our y1, -1 over our x2 is 0 minus our x1 is -3. So 3 negative times negative is +1. Negative times negative, it's +3. Okay, so 3 plus 1, 4. 0 plus 3, 3. Okay, last question. In the last question, we are working with a parallel line. It's simpler than a perpendicular line because the gradient of the lines are going to be the same. So I've been given this line 2y minus 3x equals 5, right? So for us to get the gradient from here, we need, of course, to make y subject, which we can do by taking -3x that side. It becomes +3x plus 5. Okay, we divide both sides by 2. I mean everything by 2. This goes, y is equal to 3 over 2x plus 5 over 2. Okay, so our m for the first line, we'll call it m1, is 3 over 2. Okay, this is the same gradient for the parallel line because parallel lines have got they have got equal gradients. So even m2 is 3 over 2. Now that we know the gradient of the parallel line and we have been told that it passes through -2, 3, we can find the equation. We know the standard equation is y is equal to mx plus c. We know what our m is, which is 3 over 2 x plus c. Okay, so they have said, of course, it passes at -2, 3, -2, 3, meaning that this is our x, this is our y, and that means that we're going to put 3 here and 2, -2 there. So it's going to be 3 over 2, -2 plus c. Okay, so it's going to be 3. So here you can cancel like this. Okay, we are going to remain with -1. 3 times -1 is -3 plus c. You can bring -3 this side, it becomes +3 equals c. 3 plus 3 is 6 equals c. Okay, So this is your C. Now that you know the C, you can put it here. Okay, you have this. You want to find the gradient. Now let's find C. So we have y is equal to 3 over 2 x plus c, right? So where there is c, we put the value of c we are from calculating, which is 6. So this is the equation.